Good morning, Year 4, and welcome to our first lesson of week 3 of our home learning. We are going to be continuing our learning on fractions this week and looking at ordering and comparing them. So I'm going to share my screen and let's get going. So you can see for your Do Now, you've got a range of flags on your screen. So Cameroon, Egypt, Uganda, South Africa, Mauritius, Rwanda, and Tanzania. Now they all look a little bit different. I want you to think about what fractions can you identify in these flags. So think about how many parts there is. You might want to think specifically about the different colours. And most importantly, are they equal parts? So if you want to pause the video, have a think about that, have a discussion with somebody else at home if you've got someone there with you, or have a think to yourself and then come back when you're ready. Okay, so hopefully you've managed to have a think or a chat about that. So let's have a look at them together. So if I look at the first flag, I have 1, 2, 3 parts, and I can see that they're equal. If I don't think about the star in there, there are 3 equal blocks of colours. So each one would be representing a third because there are 3 equal parts. So 1/3 is green, 1/3 is red, and 1/3 is yellow. Similarly with the Egypt flag, it's also split into 3 equal parts, but going in the opposite direction. So each part would also represent a third, 1/3 red, 1/3 white, and 1/3 black. If I look at the Ugandan flag, similarly again, I have 1, 2, 3, 4, 5, 6 equal parts. So it is in 6. However, 2 of them are black. So 2 6 are black, 2 6 are yellow, and 2 6 are red. Okay, the South African flag would be a little bit trickier for me to work out any fractions because they're not in equal parts because of the pattern. So hopefully you didn't manage to work out some fractions for that one. Similarly with the Tanzania flag, it's a bit tricky to work it out because obviously the parts are all different. But if I look at the Rwandan flag, I can see there are 2 equal parts here, and then the bigger part is the blue section. Now you might have thought that's not split into an equal fraction because the parts are not equal. However, I can use my knowledge to begin to work that out. So if I was to separate the blue part into 2 parts, then I would have 4 equal parts because that blue part is taking up half of the flag. So I could say this flag is made up of 1/4 green, 1/4 is yellow, and then I have 1/2 or 2/4 which are blue. So a little bit trickier that one, but well done if you managed to see that that was half of the flag there, okay, because I can begin to break it up, which we're going to be looking at further on in our learning. And then the last one we had was Mauritius. So you can see there are 1, 2, 3, 4 equal parts. So again, each part is representing 1/4. 1/4 red, 1/4 blue, 1/4 yellow, and 1/4 green. Okay, we're going to move on to today's lesson. So as I said, we're going to be looking at comparing and ordering fractions. So let's just recap our key vocab, our star words, because it has been the weekend. Hopefully we've not forgotten what they mean, but we have got a couple of new things we're going to be looking at today. So my turn, your turn. Numerator, denominator, order, equivalent, greater than, less than. Fantastic. So hopefully we've remembered what the numerator and denominator are, because we've been looking at those for quite a while now. So the numerator, remember, is my top number and the denominator is my bottom number. Fantastic. We're going to be looking at ordering them today. So it could be from smallest to largest. It could be from largest to smallest. That would mean that it's in order either way. And then also we should know the meaning of equivalent now because it sounds like equal. They are equal to each other. And then we're going to be comparing using our greater than and less than symbols today. Okay, let's get going. So comparing fractions with the same denominator first. So as you can see, we've got 7/8 and 3/8. So both have the same denominator. I want you to think, which fraction is greater and how do you know? Which fraction is greater and how do you know? So a little bit of a thing to get you thinking. If I was to cut a cake up into 8 pieces, because 8 is my denominator, 8 parts, would you rather have 7 pieces of cake or 3 pieces of cake? Now you might have said, I want 3 pieces of cake, because 7 pieces of cake would probably make me feel sick. Or you might want 7 pieces of cake because you love to eat it and you want more. Hopefully you've recognised that 7 is the largest numerator, so I would have more parts. So let's just look at that in a diagram to help us. So here's the number lines we were looking at in our previous learning. So I've got 7 eighths, 1, 2, 3, 4, 5, 6, 7, and 3 eighths, 1, 2, 3. So you can already see that 7 eighths is larger. The parts are the same size because they're both eighths, but I have more of them in 7 eighths. Okay, I've got 1, 2, 3, 4 more eighths, 4 more slices of cake, 4 more slices of pizza, 4 more pieces of chocolate. So it depends if you like that, whether you would want more. So if the denominator is the same, the fraction with the greater numerator will have the greater value. So we're just going to think about now, is this always true? So if they have the same denominator, a different numerator, the largest numerator is always going to be my largest. So let's have a look at some examples to see if we can prove this. So number 1, 1/5 or 3/5. So thinking in your head, which one do you think is greater? They've both got the same denominator. They're both cut into 5 pieces. Here we've got 3, here we've got 1. Which is going to be the greatest? Let's just use our bars to help us. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to show 1/5 on my top bar. Just going to call that one in. And then 1, 2, 3 on my bottom one. So instantly we can see that 3/5 is my greatest fraction. Okay, looking at the next one. So this time I've got 8 on my denominator because each one is cut into 8 parts. That is my main part that I'm looking at to check first. And then I can look at my numerator because they're the same. And then I've got 4 and 2. So hopefully you can probably recognise which one is the greatest. And that would be, well, let's have a look. So I've got 1, 2, 3, 4, and then 1, 2. So hopefully that's confirmed what you were thinking, and the largest one is 4 eighths. So we're starting to see now, hopefully the last one will help us confirm that this is always true. So I've got 5 ninths or 6 ninths. So which one do you think is going to be the biggest? Hopefully you're saying 6 ninths. We can see the denominator is the same and 6 is going to be the largest, but let's just prove it. Let's show it in our bars. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I can see on the bottom 6 ninths is larger than 5 ninths. So if the denominator is the same, the fraction with the greater numerator will have a greater value. This is always going to be true. Okay, let's have a look at fractions with the same numerator now. So as you can see now, I've got 3/4 and 3/5. So it's a little bit trickier because we've got the numerator, which is the same. So I've got the same amount of parts, but the denominator is telling me the parts are different. They're different sizes. So before we have a look at some representations to help us, I want you to think in your head. I'm going to think about the cake again. If I was to cut a cake into 4 pieces, and then I was to cut a cake into 5 pieces, which cake would have the bigger parts? So I've cut one into 4 pieces and one into 5 pieces. Which parts are bigger? Are quarters bigger parts or are fifths bigger parts? So hopefully you've had a little bit of think about that in your head and you're starting to picture what it would look like. Let's have a look at some different representations to help us imagine that. So 3/4, I have 1, 2, 3, 4 parts and 3 of them are shaded. On this side I have 1, 2, 3, 4, 5 and 3 of them are also shaded. So each one has 3 shaded, but can you see which one is bigger? So hopefully you can see that the parts on my quarters are bigger than a fifth, okay, because this is cut into smaller pieces. I've got 5 pieces rather than 4. So instantly we can see that 3/4 is larger. So it's a little bit confusing because sometimes people often think it would be this one that's bigger because that is a bigger number. But we have to remember that that is referring to, my denominator is referring to how many parts there are. So the more parts there are, the smaller that they're going to be. Okay. So let's look at another example. So I've got 1, 2, 3, 4, and again 1, 2, 3, 4, 5. So I've got my 3/4 and 3/5. So again, we can see quite clearly that 3/4 is larger. Excuse my not very straight line, I should have a ruler. And equally here, just a very similar representation, 1, 2, 3, 4 parts, and 1, 2, 3, 4, 5. We've got 3 shaded in each one, and then you can clearly see again that my 3/4 is much bigger. Okay, right, let's have a look then. So what can we say about fractions with the same numerator? So we said fractions with the same denominator, it will be the largest numerator, that's the biggest one. So what could we say about these fractions? So I want you to pause the video, have a little think, and then come back when you're ready. What would you say the rule is here? Okay, hopefully you've had a little bit of a think about that. So if the numerator is the same, then there are the same number of parts. So both of these are 3. We have 1, 2, 3, 1, 2, 3. The fraction with the smaller denominator will have parts that are larger. So the smallest denominator has bigger parts because they're cut into less pieces. So that fraction will be greater. So 3/4 is the bigger one here because it has the smaller denominator. Okay, let's see some different fractions now. How could we compare the size of these ones? So I have 2/3 and 4/9 this time. So this child is saying the numerator is greater, so the fraction must be greater. So he thinks that 4/9 is greater because it's got a larger numerator. Now, we know that would be true if the denominators are the same, which we've already looked at, but as you can see now, I've got a different denominator as well, so it's going to be a little bit trickier to work out. So first of all, I'd just like you to look at them. What do you notice about them? Is there anything that you can apply from our learning that we've already been doing? You might want to pause and have a think about that, and then we're going to talk through it together. Okay, so a couple of things that we can use to help us if the denominators and the numerators are different. We might want to think, is each fraction greater than or less than a half? Now, if I look at my two fractions that I've got in front of me now, I'm not sure that will be very helpful because I have a 3 and a 9. So it's a bit trickier to find half of those numbers because they're not even. They can't be divided by 2. So at the moment, that is not going to help me. That might help me for some of my fractions later if they are even numbers, but at the minute, I'm not so sure that's going to be useful. So my next question was, can we use equivalent fractions to help us? So hopefully if you pause the video to have a think, you may have noticed that 3 and 9 are in the 3 times tables. They are multiples. 9 is a multiple of 3. It can be divided into 3 can be divided into 9 3 times. Okay. You may also have noticed that the numbers on the top are multiples as well of the 2 times tables. However, if I look to see if there's a relationship between them at the minute, let's see if that works. So 3 times 3 is 9, and 2 times 3 does not give me 4. So let's have a think at how we can do that to help us compare them. So we'll look at a representation first, and then we're going to look at how we can calculate it, because we're not going to always have our fraction wall and our bar models there to help us. They're very useful tools to help us understand it, but then we want to also be able to do it without having those in front of us all the time. So on my top bar, I have 1, 2, 3 parts. So I know this is representing my thirds. So I'm going to shade in 1 and 2 of them. Okay. Not very neat colouring, I do apologise, but we can see that is representing 2/3. And then on my bottom strip, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I need to represent 4 ninths. So I'm going to shade in 1, 2, 3, 4. So straight away, I can see that 2/3 is larger than 4 ninths. So that's a fantastic way to help me find out. However, as I said, you're not going to always have a fraction wall in front of you, and sometimes it's going to be a little bit trickier to draw it and make it accurate. So let's have a look at how we can calculate that. So you can see again another representation with your number line, but again, it's going to be very tricky to draw a number line out as well, like we had to go out in our previous lesson. I already did them for you because it's a little bit tricky to get the intervals nice and equal. It's really important that they're equal. Okay, so I want you to look at the denominators, which we already looked at in the previous slides, 3 and 9. What could I do to help me compare these fractions? You might want to pause the video and have a little think, and then I'm going to explain. Okay, so hopefully you've had a little bit of a think about that. The diagrams might have been useful as well. So 2/3 and 4 ninths, I know that 3 and 9 are in the same times tables, the 3 times tables. And we've been learning about equivalent fractions over the last few lessons. So what I'm going to do is see if I can change this fraction into ninths to help me. Because if I look at my diagrams, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 parts, and 1, 2, 3, 4 of them are shaded. If I was to break this up into similar equal parts, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, can you see now how many are shaded? I already knew it was bigger, but now I can see that 6 out of 9 parts are shaded. So let me see how I'd convert that. So 3 is my denominator here, and 9 is here. So to get from 3 to 9, I needed to multiply by 3. I broke my diagram up into 3 more parts. And then if I do 2 times 3, as we've been practicing, it equals 6. So that is exactly what I've just worked out in my picture. So 6 ninths is the same as 2/3. So now that I have 6 ninths and 4 ninths, I can compare them really easily. I don't even need my pictures there to help me. So let's have a look at some examples of that where you can go along with me and practice without having the diagrams there to help us the whole way through. So I have put the bars there for us to check afterwards, but we're going to do it without shading first, and we'll just use that to check that it's worked. Okay, so we have our steps to success on the side. Now the first thing I need to do is make the denominators match. Which one must I change? So I need to look for the greatest multiple. So I want to know what is greater out of 4/5 and 7/10. So 10 is the bigger denominator. So I know that I'm going to have to change this one. I could make this one smaller, but I'm not going to be able to divide 7. So I'm always going to change the smallest fraction to match the biggest one here. So 5, I'm going to be changing to 10 so that I can compare the same number of parts. Okay. So I've changed that and found the greatest multiple. The next thing I must find out is what must I do to get from the smallest denominator to the greatest denominator. So how do I get from 5 to 10? So I'm going to find out how many times 5 can be divided into 10. I'm going to do my 5 times tables to help me. 5, 10. Oh, it's 2 times. It's double. So times 2. And I'm going to record this to make sure that I don't forget. So the next thing I need to do, step 3, is whatever I've done to the bottom, I've times it by 2, I now need to do to the top, which is the numerator. So I'm going to do 4 times 2. 4 times 2 is 8. So I've now done the same and I've changed it. Now, Now that I've got two fractions that have the same denominator, as we looked at the beginning of the lesson, I can now compare them really easily because I just need to look at which numerator is greater. So the fraction with the greatest numerator is the greatest fraction. So I know that 8/10 is larger than 7/10. So I can use my greater than and less than symbol to show that 8/10 is the largest. So I've done step 4. But let's just check on our fraction rule, because if you want to use your fraction rule later to help you in independent tasks, you can. So I'm going to go back to the original question, which was 4/5. 1, 2, 3, 4, 5. This one's representing fifths, and I'm colour in 1, 2, 3, 4 out of 5. And below I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I need to shade in 7 of them. 1, 2, 3, 4, 5, 6, 7. So as you can see, 7/10 is definitely smaller on the bottom than 4/5. But I didn't need to use my fraction rule to help me because I've already converted it, and I know that 8/10 is the same as 4/5. So if you see, if I was to colour in an extra one to match my bottom bar, it would also be 8/10. Okay, right, let's look at another example. So following the steps to success this time, I want you to be thinking, now that I've showed you how to do one, and be helping me as we go along. I know I can't hear you, but I'm going to be trust that you're joining in. Right, so step 1, make the denominators match. Which one must I change? Look for the greatest multiple. So I have 5, 6, 11 twelfths. I have 6 and 12. Which is greater out of 6 and 12? Hopefully you're saying 12. So that is what I need to change my 6 to. So I've done step 1. Now I must find out what I need to do to the smallest denominator to get to the greatest. So how do I get from 6 to 12? How many 6s are in 12? Thinking in your head? Let's count it together. 6, 12, fantastic. It's 2 again. So I've done step 3. Now, whatever I do to the bottom, I must do to the top to make it equivalent. So looking at my numerator, I have 5. I need to make sure I multiply that by, it must be by 5 as well. Okay, can you see what I've done wrong here? What do I need to multiply that top number by? Hopefully you're saying, Miss Jones, you need to be doing it by 2, because I've multiplied the bottom number by 2 as well. 6 times 2 is 12. This is why it's really important that we're recording that to remind us and we don't get confused. So 5 times 2 equals 10. Fantastic. So now I know 5 6 is equal to 10 twelfths. So I can compare which fraction is greater. Now thinking to yourself, is 5 6 greater or is 11 twelfths greater? Hopefully you can now tell me that 11 twelfths is greater because this one has 10 and 11 is greater than 10. We have the same denominator. Let's just check using our fraction rule again, and then we can continue and have a go without it. So my first one, I had 5 6, 1, 2, 3, 4, 5, and then 11 twelfths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So as you can see, my bottom bar is larger, 11 twelfths is bigger than 10 twelfths. Okay, let's look at another example. Okay, so step 1, make the denominators match. So thinking to yourself this time, what is my denominator going to be here? Good, that should be 12, because 12 is the largest denominator, so I need to change my 2 quarters. Okay, so next thing I need to do, looking at the steps, what must I do to the smallest denominator to get to the greatest? So how many 4s are in 12? How many 4s do I need to what do I need to multiply 4 by, to get to the 12? Okay, let's do it together. 4, 8, 12. Okay, it's not 2 this time, it's actually times 3. 4 times 3 equals 12, making sure I've recorded that. Okay, next step, whatever I do to the bottom, I've multiplied by 3, I now need to do to the top. So I'm going to multiply 2 by 3 as well. 2 times 3. 2 times 3 is equal to 6. Well done if you said that. Okay, so I've done step 3. Now I need to look at my numerators because my denominator is now the same. I have 6/12 or 5/12. So thinking what is greatest out of 6/12 and 5/12. Fantastic. Hopefully you've told me that 6/12 is larger because it has 6 parts and this one only has 5. Now I could shade that in to show that I have worked out correctly, but now that I'm confident in converting, we don't need to use the fraction rule. If you choose to do that later, you can, but you don't need to if you're really confident with changing this to equivalent fractions. Right, what I would like you to do now before we go off and do our independent task, there's a couple of questions on your screen just to check that you're confident before you go onto your banded sheet. So you're comparing 2/4 and 6/8 and 4/6 and 15/18. So a little bit trickier on this one, but have a go. Your fraction rule is there to help you. If you need to draw it out, that's fine. Follow the steps and then we will go through these together before you go on to your independent task. So pause the video and have a go, come back to check, and then we will get on to our first part of our independent work. Off you go. Okay, hopefully you've had a go at that. So let's look at those together and check if we've got them correct. So 2/4 and 6/8. So I know that 8 is the bigger number there, so I need to change 2/4 into 8s. So to get from 4 to 8, I need to multiply by 2. So remember, I wouldn't have done that to the bottom. I need to do the same to the top. Step 3 is to multiply this one as well by 2. 2 times 2 equals 4. So I can easily compare my fractions. So now I can see that 4/8 and 6/8, 6/8 is greater because it has the larger numerator. So this one is the largest. Well done if you managed to get that correct. You may have used the fraction rule to help you, which is absolutely fine. But for the next one, it had 18, so you wouldn't have been able to use your fraction rule. So let's see if we managed to get that one correct as well. So straight away, I'm going to compare my denominators. I have 6 and 18. 18 is larger, so I know I need to change this one into an equivalent fraction. So I need to first find out how can I get from 6 to 18. So I'm going to count my 6 times tables. 6, 12, 18. That's 3 times. 3 times 6 is 18. Okay, I now must do whatever I do to the bottom to the top. So 4 times 3 equals 12. Okay, so I've now got 12/18 is equal to 4/6 and 15/18 is equal to that as well. So which fraction is larger out of 12/18 or 15/18? Hopefully you've recognised that 15 is the larger numerator, so this one on this side again was the largest. Now I hope you've managed to grasp that. If you're still finding it a little bit tricky, I suggest going back in the video and re-watching those ones again and coming back and having another go. Make sure you're following the steps as well to help you. If you're confident and you're happy to go off and have a go on your own, your banded sheet is in your home learning, so it should look like this. Now, I would just like you to go away and have a go at the use first, because then we're going to have a look at the apply together because it's a little bit different today. So band 1, you've got the fraction bars to help you shade, to help you work them out. Band 2, you need to be using your equivalent fractions to find the greater, and band 3, you're going to be saying which is true or false. So looking at each question, is it true or false? So pause the video, have a go at those and come back for the apply when you are ready. Good luck, off you go. Okay, hopefully you've had a go at that. The answers are in the home learning sheet, so make sure you've marked it and check that you're confident before you move on to the next part. If you're getting quite a few wrong still, I would suggest going back in the video and watching that again before you move on to the next part. So now we're going to look at ordering numbers on a number line. Now, you can see my number line is blank, so it's going to be a little bit tricky to know exactly where they need to go, but we're just going to be estimating and using what I know. So first of all, I'm going to label the end of my number line 0 and 1 because all my fractions are smaller than 1. Okay. So I've got 1/2, 3/4 and 1/8. So I'm going to use my knowledge of what I know about fractions. I know half goes halfway between. Now it's not going to be perfect, but I'm obviously not going to put it down here. I need to make sure it's as far in the middle as I can get, as accurate as possible. 1/2 is going to go here. Now we should be a little bit confident with this because we have been looking at number lines in our previous lessons. So let's have a look at the next one, is 3/4. So I know that it needs to be 4 parts. Now I could just guess where that goes, but because I've already found half of the number line, I can now break it into smaller pieces to help me. So I know 1/4 is half of a half. So that would be this, that would be 1/4, 1/2, and then in here I would have my next quarter. So 1/4, 2/4, 3/4. So I know that 3/4 is going to be roughly about there. Now, as I said, it doesn't need to be perfectly accurate, but obviously you need to be thinking about the distance between them and how you're going to break it up. So I've done 3/4. Now 1/8 is my next fraction, so I need to have 8 parts. But you should be able to recognise that 8 is a multiple of 4. So I'm just going to need to half my intervals again. So if I have 4 here, I can straight away just half these ones to make it 8 sections. So let's just check that. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, or 1/2. Fantastic. So I've got 8 roughly equal parts. So I know that 1/8 is going to be on this first one here. Okay. So that's what you're going to be doing for your apply. Let's just look at a couple more examples together to check that we've got that. So again, I'm going to start with 0 and 1. And then I'm going to look at my fraction. So again, this time I've got quarters and 8. So I'm going to start by putting half again because I know that it's an even number that I'm looking at. So finding the halfway point first is really going to help me. So I know this is a half, and then I can break it again like I did in the previous one into 4 sections. 1/4, 2/4 or a half, 3/4 and 1/2. So I know that 1/4 goes here. So what am I going to do now to find 8? So think about what I did in the previous one. What do I need to do? So hopefully you remember I broke it up into smaller sections because quarters, an eighth is half of a quarter. 2/8 make up 1/4. So I can break that up to find 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Okay, not totally accurate, but I'm just estimating and doing my best to make it as equal as possible. So I know that we've already done 1/4. I can count my 8s now. 1, 2, 3. 3/8 is going to be here. And 3, 4, 5, 6, 7/8 at the end right before 1/2. So if I was going to ask you to order these fractions, you might look at it and think, oh gosh, that's a little bit tricky because one of them's got a different denominator. So we can find the equivalent fraction like we've just looked at, but we can also use the number line to use our knowledge to help us order them without having to convert any to different fractions. So straight away, I can see that 1/4 is the smallest fraction, 3/8 is the next smallest, and 7/8 is the greatest out of these 3 fractions here. Let's have a look at one more example before you go off and do this on your own. It's a bit tricky this time. So I've got 1/6, 2/3, and 4/6. So I'm going to start again doing 0 and 1. But this time it's not really going to help me doing the halfway point because I need to break my bar up into 3 parts to find 2/3. So it's going to be a little bit trickier to do in thirds, but I'm going to be as accurate as possible and say that I'm going to say 1/3 is here, 2/3, and 1/2. Let's just check that. 1/3, 2/3, 3/3. So I know that 2/3 is going to be roughly about there. Now, you've probably recognised I've put these together because 6 is also in the 3 times tables. So I can half my parts again to make 6 parts because a 2/6 make up 1/3. So I have 1/6, 2/6, 3, 6, 4, 6, and 5, 6. So let me just label my parts. I need to put 1, 6 on. So 1's going to be my first jump here. I need to count to 4. 1, 2, 3, 4. So 4, 6 would be on this one here. Now, what do you notice about these ones? Hopefully you can tell me that they're equivalent fractions, because 2/3 is the same size as 4, 6, just like we were looking at on our fraction walls and number lines. So 1/6 is the smallest fraction, and then 2/3 and 4, 6, it wouldn't matter which way around they came in order because they're both equivalent, they're both the same. But the important thing is that I know 1/6 is the smallest. Okay, a little bit tricky to do that, but remember you're just estimating using your knowledge, so don't worry if your sections are not equal. And if you can't print the sheet off, obviously you can draw out your own number line because you're going to be filling in the intervals anyway. Okay, so it doesn't really matter how long it is as long as we start with 0 and 1. So hopefully you finished your U section. You can now go on to have a go at the apply. So there are a few number lines in band 2 and 3 to help you, and then in band 1 there's just a missing fraction there. I would say if you're doing band 1, do try, if you're feeling confident, to go and have a go at those ones, because I have just showed you how to do it. See if you can at least have a go at A and challenge yourself. And then when you get onto the reason, there is an explanation for you to do. When you finish that, make sure again you check the answer sheet to see how you're doing and come back and have a look again if you're not sure. And then we've got another question to go through together. So pause the video, have a go, and then come back when you're ready. Fantastic. So I hope that you managed to have a go at that and you're feeling a little bit more confident. Don't worry if you're not. You can make sure you tell your teacher and we'll go through it with you in the briefings, and then hopefully I can put some things in the do nows to help us go over that again as well. Let's just look at one more question together though to make sure that we've understood our learning today. So Emilio completed 1/2 of his online learning. Jenny completed 5/8 of hers. Who completed the most? Now, I could go on straight to compare it on my fraction wall, but again, we're just going to use that to help us check our answer. I want to be comparing my fractions, how we've been learning today. So I'm looking at 1/2 and 5/8. Which one is greater? Now, at the beginning, I said we might be able to use our knowledge of halves to help us. Because when we were looking at equivalent fractions, we said that if it's equivalent to 1/2, the numerator is always going to be half of the denominator. So I know that I need to change this one to 8s, otherwise I'm not going to be able to compare them easily. So without having to even convert my answer, I know that the numerator needs to be half of the denominator to make it equivalent. What is half of 8? Fantastic, half of 8 is 4. So let's just check that that works to make sure it's accurate. So 2 times 4 is 8, and 1 times 4 equals 4. Fantastic, so that is the equivalent fraction. So now I can see that 5/8 is larger because it's got the larger denominator and 8 equal parts. So 5/8 was the largest fraction, so who completed the most? Jenny completed the most homework at online learning. Well done, Jenny. So let's just check that in my fraction wall. So Emilio completed 1/2, Jenny completed 1, 2, 3, 4, 5/8. So straight away we can see that it is larger. Okay, so I hope you have enjoyed today's lesson, everybody. I'm just going to stop sharing my screen with you. Great work. Good start to the week. I hope that was nice and clear. If you're still finding it a bit tricky, remember, post your work on Seesaw. The teachers can give you some feedback and help you in your meetings. So good luck with all of your work. Make sure you're posting to Seesaw. Enjoy the rest of your day. See you tomorrow.